2, 3, 4, 5, 6, 3.
Hey, what's up, guys? What's going on? Welcome back, man. Feels good to be back. 6 more weeks to go. 6 more weeks. We almost done, y'all. Anyway, man, hey, I'm going to go through Unit 12.0 and 12.1 notes real quick, man. These are y'all did transformations several times throughout the year. So let's dig in, man. The main thing I want to hit on is these example of transformations and go into a little detail about them. The first one I want to talk about is the negative in front, guys. All right, when you have a negative, it reflects over the x-axis. All right, so a negative out front, let's say you had an equation, f of x equals negative 2x. Right? This tells me I'm going to reflect the x-axis, okay? All right. Now, let's say you had a negative inside. All right, negative inside. Well, that would be f of x equals all right, negative inside, okay? This means reflect the y-axis. So reflect the x-axis. Let's say hypothetically this was a parabola. All right, reflect the x-axis. If it was like this, then it would be like this. All right, it goes down. All right, and reflect the y-axis. Let's say it was like this. Well, it reflects to the other side of the y-axis. All right, so that would be reflect the y-axis. Okay. All right, next we have the a value. The a is the value that is right in front of the function. So again, let me make up a function. F of x equals negative 2x plus 3 squared minus 4. All right. Now, let's talk about the a. Your a here is 2. All right, your a is 2, not negative 2. Reflect the x-axis. This negative on the outside says reflect the x-axis. That's nothing to do with this 2. All right, this 2 is greater than 1. All right, it's a positive 2. A is always positive. All right, so we have a positive 2. That's greater than 1, so we're going to have a stretch. All right, we're going to have a stretch. So where your original graph would be like this, it just stretches longer. All right, it gets longer. All right. All right, so there's your vertical stretch. Horizontal compression, this thing's gonna get fatter. But anyway, your a value, all right, your a value, this should be a. Your a is greater than 0 but less than 1. Really, guys, I look at it like this. It's just less than 1. All right, a fraction. All right, this could be a fraction or a decimal. All right, or a decimal. All right, a decimal less than 1. All right, so 0.5, 0.873. All right, not 1 point something or 2 point something, but less than 1, a decimal less than 1. All right, so a right here is 1/2. All right, that's less than 1. All right, a fraction, this will work. But remember, the numerator has to be smaller than the denominator. All right, so let's say it was 5/4. Well, that's larger than 1, right? That's 1 1/4. We don't want that, right? That's an actual vertical stretch. All right, you want it to be less than 1. Excuse me, you want it to be this fraction to be less than 1. That's greater than 1. This is less than 1. All right. So make sure you look at your fraction. But again, this is a compression, vertical compression. All right, vertical stretch because that's greater than 1. All right. All right. Next we have the horizontal. Whoa. Didn't mean to do that. Clear the ink from the page. There we go. Horizontal shift. All right, horizontal shift. All right, with h. Remember, guys, if you have plus h, all right, plus h, you move this thing to the left. All right, and if you have minus h, you move this thing to the right. All right, here's what I mean. All right, let's say you have f of x equals this one right here, x plus h. This is h. All right, This is h. 3 is h. This is plus h. So we're going to go left. All right, you do the opposite. All right, and if we had f of x equals negative 2 times x minus 3. All right, this is h, negative 3. Man, you move that thing to the right, okay? Move that to the right. All right, next we have k. All right, plus k means go up, minus k, go down. All right, go down. So let's say you had f of x equals negative 3x plus 2. I'm going to do it like this. Minus 6. And you had f of x equals negative 3x plus 2 plus 6. This one right here, this k value here, means down 6. All right, because it's minus 6. See, minus k. All right, this is k value. All right, and then this 6 right here means up 6. All right, because it's plus 6. Plus k is up, okay? All right, next, we're going to talk about these functions here. All right, a quadratic. All right, we know it's quadratic because the degree here is 2. All right, that tells us it's quadratic. All right, guys, you have a parabola here. All right, that's not a very good parabola. All right, but there you go, parabolas. Okay, you have parabolas. For the absolute value function, all right, absolute value, we just did a test over this, guys. All right, but what you get is the V-shaped functions. All right, I hope y'all remember this. These are V-shapes. All right. And then for the radical, all right, I don't know if you remember this. We did this last semester, but a radical function, guys, will look something like this. All right. Okay. That's that. All right. Well, that's 12-0, guys. All right. I'm going to go ahead and continue to 12-1. We're just going to put them together. They're really short. All right. All right. These are 12-1 notes right here. And the thing about this is this table, you've seen this table several times. We've used it. We recycled it plenty of times, man, straight from the textbook. But again, man, plus K, all right, means up, all right, up 3, down 3, minus K will be down 3, all right, minus H means right, all right, plus H means left, all right, the A out front means if the A is greater than 1, like this, it's a stretch. If the A is less than 1, it's a compression. Right here for horizontal stretch, all right. If you have a fraction, all right, basically if it's a fraction that's less than 1, you have a stretch by the reciprocal. So whatever that is, you would do the reciprocal. See how this is 1/5, all right, that's less than 1, well, you're going to stretch it by 5. The reciprocal 1/5 is 5. If you flip it, you get 5 over 1, which is 5. Right here, you have 3, where the reciprocal is 1/3, so you have a compression by 1/3. All right, and then the negative out front means across the y-axis, reflection across the y-axis. The negative in front of the x means across the, across the x-axis if it's a negative out front, across the x-axis. And negative in front of the x means across the y-axis, all right? Okay. For this first example right here, all right, it says given f of x is x cubed plus 2, and g of x is f of x translated down 5 units. All right, here's what you have, f of x minus 5. Well, we know that this is f of x, right? And we're going to go down 5 units, so minus 5, all right, which is shown right here. All right, this is f of x. All right, we have f of x minus 5, f of x minus 5. All right, and then we just simplify. Well, we can simplify this. 2 minus 5 is negative 3. All right, so you have x cubed minus 3. All right, you do like terms. X cubed minus 3. So this is simplified. All right, I'm not going to spend a lot of time graphing because, man, on the quiz, it's not. The graphs will be given to you. So you just need to know how to look at the graphs and identify the transformation, okay? By the way, this is your y-intercept. All right, just so y'all know, like, see how this right here, x cubed plus 2, the center of this graph, and I can just do a rough sketch just so y'all see. This is it right here, 0, 2. I can tell you that right now by looking at this graph. And it's cubic, so it does something like that. Well, see how when we simplify minus 5, we get negative 3? Well, if you move down 5, 1, 2, 3, 4, 5, you're right here at negative 3. So this graph will continue to do the same thing. All right. So I'm just showing you that, yo, if you know the y-intercept, you can move this thing how you want to move it, based off the information that's given. All right. Or if I solve this algebraically, I get negative 3. That's where my y-intercept is. That's my new one. That was my old y-intercept at 2. That's my new y-intercept. All right. If you don't believe me, graph these. Graph these, and I promise you, this is where they cross the y-axis. All right, you try. It says, what would the equation from the function h of for a function h of x be translated f of x up 1 unit? All right. So again, remember f of x up 1 unit, f of x. So we have f of x plus 1 up 1. So again, the original equation is x squared. I'm sorry, x cubed plus 2. And we're going to go up 1 unit. So plus 1. All right, this is f of x. All right, this is f of x. All right, this is f of x. This is plus 1, up 1. So we end up with x cubed plus 3. This is our h of x function. All right, h of x. Man, my slate is tripping today. But h of x, okay? This is h of x. All right, B horizontal translation. All right, well, I don't have a value for it. So, all right, B, this is part B. Okay, cool. A horizontal translation of h units right is accomplished by replacing the x variable with h. All right. So again, if you go right, remember it's minus h. All right, if I want to translate it left, I'm going to go plus h. All right, so in this example here, it says transfer f of x, to translate f of x from the above example 4 units to the right. Well, again, remember you have x cubed plus 2, right? And we're going to go to the right 4 units. So to the right 4 units will be minus 4. All right, so y'all see this? H is directly added or subtracted to the x. So what you get is h of x, or is it g of x? G of x, sorry. All right, well here, g of x equals x minus 4. All right, then put the cube out here. Because again, you got to subtract it directly from the 4. All right, directly from the x. All right, this will move it right. This means right 4. All right, plus 2. The 2 didn't go anywhere. All right, the plus 2 is still here. It's just I needed to alter this with h to move it to the left. To the right. All right, so minus 4 moving to the right. So here's your crazy equation right here. And that doesn't simplify because, see, this is in parentheses. That's not. All right. Right here it says if you have h of x is 2x squared minus 3x plus 8. All right, what is h of x plus 3? Man, this is literally substitution. All right, this is substitution. The reason I say it is because here's h of x. Well, y'all see x is x, right? Like here, this is just x, this is just x, because that's just x. Well, we're going to change x to be x plus 3. All right, so now substitute this, all right, for this function now, because these are no longer x's. They're now x plus 3. So everywhere you see an x, you're going to put x plus 3. So you have 2 times x plus 3 squared. All right, and then we have minus 3 times x plus 3, right? Because again, x is now x plus 3 plus 8. All right. Now, I know off first glance, man, you guys are like, oh, I can distribute the 2. No, you can't. You can't distribute the 2 because remember, you have this squared right here. All right. This square tells me I can't distribute that 2. I would have to evaluate that. And on a side note, all right, x plus 3 squared is the same thing as x plus 3 times x plus 3. All right. You can't just distribute the 2. All right. You can't. Okay. So what you do is we're going to leave that because we're going to talk about the transformations. All right. So we have 2x plus 3 squared minus, now look, notice there's no exponent here. So we can distribute that, right? 3x minus 9. That's negative 3 times x, negative 3x. Negative 3 times positive 3 is negative 9 plus 8. All right. Then let's simplify it one step further. All right. That isn't going to simplify, so we get 2x plus 3. Well, it does simplify, but for the sake of identifying the transformations, we're not going to do it. All right. Minus 3x minus 1. All right. Negative 9 plus 8 is negative 1. Okay. There's our function right there. All right, over here for B, I just want to talk through this. Oh, wrong thing. Here it says identify the transformation. What would it take to go from f of x to g of x? All right, well, first of all, let's look at the h values. All right, the h values. All right, to go from 1 to negative 3 would be minus 4. Well, if we're going minus 4, that means right. Remember h. You go minus, you go right. So right 4. I want right 4. And now look at k. All right, we have negative 4 and 5. How do I go from negative 4 to 5? I would add 9. So that means up 9. All right, negative 4 plus 9 is 5. So up 9. All right, here's the transformation, okay? All right. Here, reflection polynomial functions. Here's a polynomial. All right, 2x to the 5th minus 5x cubed plus 8. All right, if I wanted to reflect this across the x-axis, you must multiply the entire function by what? All right, remember, what goes out front, all right, if we go back to our rules, what go out front to give us a negative across the x-axis? Reflection across the x-axis, you will put a negative out front. All right, so we did that right here. Put a negative out front, all right, and there's your whole equation, all right? There's your equation. All right, you put a negative out front. Now, if you do distribute it, you'll have negative 2x to the 5th plus 5x cubed minus 3. All right, that would be your equation if you went ahead and distributed negative 2 plus 5 minus 3, okay? And then you can sketch both of these in your calculator, guys, all right? And again, put the negative out front, negative 1. Negative 1 goes out front. All right, or just a negative. All right, negative 1 and negative is the same thing because this is an implied 1. All right, but you would grab both of these in your calculator to see the difference. All right. Reflection across the y-axis. The negative goes directly to the x. All right, directly to the x. So you have negative here. All right, because remember the original is 2x to the 5th minus 5x cubed plus 3. That's the original. Well, if I wanted to reflect the y-axis, all right, I'm going to put the negative in front of every x value. All right, every x. All right, so that would be it. Again, you can graph those two to see the difference. But they are reflections right across the y-axis, okay? Matter of fact, here, I'm going to do it so y'all can see it. So like we said, I went ahead, here's the original. All right, the original polynomial. And then to reflect the y-axis, you got to put the negative in front of the x's. All right, so let's sketch it. All right, and you'll see how this thing reflected. All right, there's the parent function right there. And then when you reflect it, everything flips. All right, so this point is now down here, and this point should be up here. All right, there it goes. All right, see how now the blue is reflected over here? That blue tip is reflected over here. All right, notice how this is now reflected on this side, and this point here is reflected over here on the left. All right, so there is your two graphs. All right, and you know, just for the sake of showing you, let me show you the one at the top. All right, if we were to put the negative out front, two x to the 5th minus 5x cubed plus 3. All right, this would be reflect the y-axis. I mean the x-axis. Excuse me. All right, if we reflect the x-axis. Ooh, you know what I forgot? I forgot my x. that would have been not even the same graph. Put X right here. There we go. All right. All right, parent function, and then the reflection. There we go. There's a reflection. See how this reflected down? All right, that reflected down. Because this is going down, it reflected up. All right, that tip right there reflected up. This end reflected down. All right, reflect the y-axis just flipped. All right. All right, so now I showed you the transformations, the reflections across the x-axis and the y-axis. Now let's look at compression rules. All right, compression rules and stretch rules. All right, compression and stretching a polynomial function. All right, if you want to do a vertical stretch, you would multiply the entire function by a value, all right, or a number. That's our a value. All right, that's a. All right, a is greater than 1. All right, and that'll give us a vertical stretch. If I want to do a vertical compression, I would pick an a that's less than 1. All right, but it's supposed to be greater than 0. So again, that decimal is less than 1, or fraction is less than 1, like 1/2, 3/4, all those are less than 1. All right, you know, 5/16 less than 1. All right, something like 5/2, that's greater than 1. All right, yeah, with me, that's greater than 1. Okay, so this won't work. All right, that won't work. That's greater than 1 because the top is larger than the smaller, so that won't work. All right, for horizontal compression, all right, remember, you got to do the reciprocal. Okay, so multiplying x by a number greater than 1. All right, let's say I had 2x. Well, it's going to give me a shrink. All right, it's a shrink by 1/2. All right, you do the reciprocal. All right, if I wanted a horizontal stretch, if I wanted the stretch, I would do pick a number that's less than 0 or greater than 1, or the number would be presented that's less than 1, but greater than 0 is going to be a fraction. All right, so you would do the reciprocal, all right, of 2. That'll give you your stretch. Okay. All right. So an example here would be I wanted to stretch this equation, this polynomial. So multiply the entire thing by 3. All right, so that'll give us 3x to the 4th minus 18x squared plus 18. All right, that right there would be a stretch. Okay. This one right here, if I want a horizontal stretch, all right, by 3, all right, that means that every x would need to be multiplied by the reciprocal of this 1/3. All right, so I'm going to show you. You would have 1/3 x to the 4th, all right, minus 6 times 1/3 x squared, all right, plus 6. All right, I'm going to show you with the graph real quick how this looks. All right, so again, here's the original polynomial. Here's the stretch. All right, there's the stretch right there. Just multiply everything by 3. All right, when you do that, here's your two graphs. That's the original. And then when you stretch it, here comes the stretch. There we go. See how it got longer? All right, that's a vertical stretch, okay? Now, for the other one, we have a compression, a horizontal compression, all right, by 3. All right, so you guys, I'm going to do it like this. X divided by 3, that'll be 1/3 x. Because you know 1 times x is x, so x over 3 to the 4th minus 6 x divided by 3. And we're going to square that. and then we have plus 6. All right, so this will be the horizontal compression. So we graph those. There we go. So see how this is a horizontal stretch? All right, horizontal stretch. You got to do the reciprocal. See how this widened out? All right, you got to do the reciprocal, okay? All right. Let's go back to the notes. Okay. This next part right here says transform this function x squared minus 6 by shifting it left 3 and up 7. All right, well, there's the parent function, x squared minus 6. All right, if I want to shift it left 3, I'm going to put the 3 right here by the x, like this. All right, and then keep my squared. And then I'm going to go up 7, so plus 7 on the outside. So when I do that, I end up with x plus 3 squared plus 1. All right, there's my function right there. You can check it with a calculator. For this one here, there's the parent function. All right, well, the parent function is x squared, but there's my original polynomial. All right, by reflecting it across the x-axis. So if I reflect it across the x-axis, we know a negative goes out front. And then a vertical compression by 1/2. All right, so we're going to put 1/2 out front as well. That's my vertical compression. All right, remember, the vertical stuff doesn't change. It goes exactly how it is. So we end up with x squared minus 6. All right, right there. Right here, it says identify the transformation. All right, again, how do I go from 1 to -3? All right, well, 1 minus 4 is -3. So if I go minus 4, remember that's right. All right, right 4. All right, for my h value. All right, and then how do I go from -5 to 1? All right, from -5 to 1, all right, I will add 6, right? So up 6. All right, up 6. All right, well, that concludes, man. Hey, I hope this helps you guys for 12-0 and 12-1, man. All right, prepare for the quiz. It's coming up in a couple days. All right, good luck and later.